Hey everyone, and welcome to this explainer. Okay, let's jump right into this because today we are going on a seriously fascinating journey inside your own head. We're going to explore the incredible, totally invisible life cycle of a memory. How does a fleeting moment in your day actually transform into a permanent part of who you are? And on the flip side, how do pieces of our past just completely slip away? It is a biological marvel that shapes our entire reality, and I promise you, by the end of this, you're going to look at your own brain in a completely new way.
To kick things off, I want you to do me a favor. Think back to a really vivid core memory from your childhood. Just hold it in your mind for a second. Notice the details, the emotions. Got it? Okay, now try to answer this question. What did you have for lunch exactly 3 weeks ago? Unless you literally eat the exact same thing every single day, your mind is probably drawing a total blank, right? That second memory isn't just weak, it's likely completely gone. And that really highlights the grand mystery we're unpacking today. Why does the brain fiercely protect some experiences while completely discarding others? So, here is our roadmap for the explainer today. We're going to cover what memory actually is, the different kinds of memory, how they're formed, the absolutely crucial role of sleep and consolidation, and finally, how you can defend your memory. Let's get moving. Section 1. What is memory? Taking a philosophical perspective, memory is really the biological foundation of our identity. It completely underwrites our knowledge of the world and our very sense of self.
Moving on to Section 2, kinds of memory and how we structure the mind.
So, memory isn't just one giant filing cabinet up there. Scientists divide it into systems. You've got non-declarative, unconscious habits, and declarative, conscious recall. We're going to focus on the conscious stuff today, which breaks down into two main types. First, we have episodic memory. This is your memory for the events of your personal past. When you recall an episodic memory, you experience what scientists call autonoetic consciousness. That's basically a fancy way of describing that magical feeling of mentally traveling back in time to re-experience an event. Then we have semantic memory. Think of this as your database of general facts and rules about the world. For example, knowing that Paris is the capital of France, that's semantic. But remembering the time you actually walked down the streets of Paris and ate a croissant? That is episodic. Section 3. How memories are formed, the biological journey. Let's actually follow a memory from the exact second a stimulus enters your brain. Understanding this chronological encoding pathway is absolutely key. Step 1 is sensory input, just experiencing the world. Step 2, that information lands in your short-term memory. You can kind of think of short-term memory as a temporary scratch pad. It holds a very limited amount of data, typically about 7 items, for up to maybe 30 seconds. To survive past this point, the information has to be processed by the hippocampus in Step 3. The hippocampus acts as this ultimate encoding hub, and it decides what gets passed along to Step 4, the neocortex, which is where the memory is distributed and stored for the long term.
But how does that storage physically happen? Well, it happens through a truly remarkable process called long-term potentiation, or LTP. When you experience something, it converts into a tiny pulse of electrical energy that zips along a network of neurons. Now, these neurons communicate at dedicated sites called synapses. When two neurons communicate repeatedly, like, say, when you're deeply paying attention to something or practicing a new skill, the physical efficiency of their connection actually increases. So, by actively engaging with information, you are literally, physically strengthening the hardware of your brain. How wild is that?
Now, this is where we hit the absolute frontier of science. Where exactly does a memory live? The leading consensus is synaptic plasticity, those changes in the connections we literally just talked about. But there are also theories about engram cells, which are specific, dedicated subsets of neurons that activate just to hold a memory trace. Then there's epigenetic coding, which suggests memories are recorded by actually modifying the DNA within neurons. And on the absolute mind-bending cutting edge, there are even theories suggesting memory operates at a subcellular quantum level inside tiny structures called microtubules. Science is literally still trying to work out the exact coordinates of our past.
Section 4. Sleep and memory consolidation. The night shift. Okay, if you think sleep is just a passive state of rest where you power down for the night, prepare to have your mind blown. During the night shift, your brain is wildly active. It's generating these very specific rhythms, functioning as an intense systems consolidation process. We've got slow oscillations originating in the cortex, spindles coming from the thalamus, and these sharp wave ripples in the hippocampus. And when these three oscillations couple together perfectly, it physically orchestrates the transfer of reactivated memories from the temporary storage of the hippocampus
out into the stable, long-term storage of the cortex. Your brain is quite literally replaying the events of your day while you sleep, just to lock them in.
And it turns out the different stages of sleep have completely different jobs here. Non-REM sleep, that's your deep sleep, is all about stabilizing newly encoded content. It reactivates memory assemblies and physically scales down unnecessary connections to restore balance. REM sleep, on the other hand, the dream stage, is dominated by theta waves. REM takes those stabilized memories and integrates them into your broader semantic frameworks. It abstracts the rules and tags the memories with emotion. You absolutely need both, the stabilizing power of non-REM and the dynamic integration of REM to form a complete lasting memory.
Think about how the brain's chemical environment actually changes to make this whole thing happen. During NREM sleep, there's a massive drop in a chemical called norepinephrine. This sustained low level creates a permissive state that allows for what we call synaptic downscaling. It's basically like the brain is pruning a garden. Over the course of the day, you absorb so much random, totally useless information, like what you had for lunch 3 weeks ago, right? During sleep, the brain selectively weakens these irrelevant synapses so your hardware doesn't get saturated and completely overloaded. You literally have to forget in order to remember. Section 5. Defending your memory. Thieves and protectors.
So, knowing all this incredible biology, how do we actually protect it? Well, unfortunately, modern life is full of memory thieves, which I know sounds a bit bleak. First, there's simple aging. The hippocampus loses about 5% of its neurons every decade, which leads to actual brain shrinkage. But a massive, highly controllable thief is chronic stress. When you're constantly stressed out, your body is flooded with chemicals designed for a short-term crisis. Over time, these chemicals literally result in the loss of brain cells and they halt the formation of new ones. Depression is another major culprit. A drop in serotonin reduces your attention to the present, while constantly dwelling on the past prevents new short-term memories from even forming. And finally, social isolation has been shown to rapidly accelerate memory decline. But hey, do not despair. Your brain is remarkably like a muscle. You have to use it or you risk losing it, and you have some incredibly powerful protectors at your disposal. Physical activity is massive. It directly increases blood flow to the brain, which feeds those hungry neural networks. A healthy diet provides the essential nutrients for all that synaptic plasticity we talked about. But perhaps most importantly of all, you have to give your brain a workout through novel challenges. Learning a new language, mastering an instrument, or simply integrating yourself into new social networks forces your brain to build brand new, resilient pathways.
Which leaves us with one final question for you to really think about. How will you treat your brain tonight? Every single day, your mind is capturing the world. And every night, it is furiously working to weave those experiences into the very fabric of who you are. Will you give it the sleep, the novelty, and the care it needs to preserve your personal history? Thank you so much for exploring the life cycle of a memory with me today. Keep learning, keep challenging yourself, and for sure, get a great night's sleep tonight.